Hello, ladies and gentlemen. What's up? It's Papa Bale. Welcome to the channel. And on today's live stream, I was messing with the axial flux motor, and this is what I came up with so far. We got main drive, we've got secondary drive, and generator. We've got, a third drive that's being charged up by this coil. Not directly either. I got a bridge rectifier over here, and we're gathering electricity from the two center strands of the 4-filer coil, and we're taking that energy and we're putting it into the bridge rectifier, and then we're taking also we're running this secondary motor, and it's generating a transformer like and that's how we're getting current to the third drive, is through that transformer like thing. So here we go. There's a neon light that's connected to the third circuit, and if it's on, that means the third circuit is on, right? That means it's functioning. The third transformer is running. All right, we're ready to go. Well, let's do this. We gotta have both power supplies at the same rate of input. All right, here, let's do it. It's on. Yeah. Woo-wee. So all three have their own trigger and their own power supply. You see, as long as the second drive is on, which is that power supply over there, this light will remain on because the current is flowing through the two strands in the middle. But watch what happens when I turn it off. The current goes away, there's still voltage, but the light won't light up. But as long as there's current, both work. They each have their own light. And then, well, the thing is, the secondary circuit's light doesn't turn on, the third one's light turns on because they're directly connected through the bridge rectifier. And if you didn't think the bridge rectifier connected stuff, it does. Not sure that that means that it's broken or whatnot, but it definitely. And the fluctuating rate of DC that's coming through this thing right now is amazing. Got somebody walking around my neighbor's house. See, and at 12 volts, the light won't turn on, but 15, it starts working. And you can tell when it's working right. You get some more pickup. That sounds wrong. There we go. There's something wrong with the trigger strand. That's right. $17.2 is bread and butter for this one. About 16 volts going through the bridge rectifier right now. That light is lit. There we go. That's ingenious. I'm just waiting for my microphone to charge up, and then I will have a microphone. So when I had both strands in the tri-filer hooked up to different power supplies, something happened there where it worked and then it was not working. There's nothing wrong with the transistors. I'm working with the same transistors. It's like either wires were getting crossed or the connectors aren't connecting. Stuff like that. Just real dumb stuff. So I think that's cool. This is like the first time I've actually got the light, like a demonstration of the third wheel actually spinning. Awesome. That's great. Hey, what's up? All right, so we got this. I'm still working out the kinks because you insert the power. Well, that it didn't start humming. Usually it would hum. So, the transistor's good. It's your connections that are probably not good, at least for the meantime. And then they're end up being bad. You just let that go. See, that it does that. And I don't know why. Maybe it's too much power. There, it stopped. So I don't know, like, either what's touching, because I don't see. I hope that resistor's in there enough. This thing weighs a ton, and it matters, especially, wow. Maybe that is the transistor. Don't want to give up on it just yet, but yeah, that's probably broken. Let's see. I probably need more wire too, like another coil. Probably gonna need to put another coil in here just to spread it out a little bit. It's too acute. I never done one with one coil before. Nope, flapping on something. Let me get my bearing real quick. It's a lot easier to do this with this bearing. Damn. That's going the same way though, isn't it? Yeah, that's not working. All right. Maybe we take the light out, because it looks like it's the light that's definitely the light, because it's finicky. I touch it and this stuff happens. Damn. I don't want that to hit that. It's hitting it, and I can't bend it because it's a jumper cable. Frickin', I hate wires, man. I'll tell you right now, there is no mercy. Whoever likes that rigid stuff, man, I don't know what to tell you. It's funny. All right, I think that'll work. All right, so I took the light out and that happened. Let's see if that's going to continue to happen. right. And the truth. Was it the light? Do I need another light? There's the bearing. Yeah, I think it's just too much power going through this thing, or it's just a crappy breadboard. I don't know. It's definitely in the breadboard though. What's going on here? And I've gone through a lot of transistors trying to make this breadboard thing fucking work, and it's not gonna work. So and it's like, yeah, but it's all about the connections. It's all about the connections. I don't like that. Been working with that like all night. Nothing's like touching anything else. It's weird. I don't like it. But I think I need more copper in there. Hang on just a second. What's up? She need you? Alright. Just leave her alone, okay? Take care of everyone down, right? No, we can't right now. She doesn't want you to. Sorry, I can't help you with that. Because when people don't want to do what they don't want to do, they don't have to do it, right? I'll deal with it in a little bit, but there's nothing I can really do. You understand that, right? Okay. You got it right. Awesome, and it's stable. All right, I'm going to try and hook these up. There's 2 strands that I can hook up in this coil, so I'm going to try and do a series setup with that. That's weird. See, I hooked that strand up and it's like we get nothing. I think it's because it's fragile equipment. That's the only thing I can really say about it. You can't like throw it like a football. There we go. That's what I'm looking for. Now it'll slow down quite a bit, but it'll be a much more efficient draw. That's awesome. That is a standard connection, no diode in the middle there. I should put a diode in there just to see what'll happen. Yeah, it's about a half an amp less on the draw. Almost a full amp less. So I'm gonna try and get it even lower. I don't know if this is gonna make it lower though. I love this motor though. It's really cool. No, my kids need to learn how to get along a little better. All right, let's turn it up. Heck yeah, wow. We were at 0.5 earlier. Well, we're about 0.5 now. The DC version. You really got to put it up to about 17 volts to get a steady function through the third transistor load. And by suggestion, I put a cap on my rotor so the magnets don't go flying. See, this light right here isn't turning on because it's all right here. There's a flow through. That's really cool. I need, where can I put it? I know I've seen it somewhere. Here it is. I don't think I have a tack on here to read. One 666 in the middle there. 1669. So that's a pretty good reading, I guess. I'm gonna get a piece of tinfoil on that. I do say that 1600 sounds about right though. So primary drive is off, secondary drive is still running. And the third drive is still running as well. think I want to put a cap on this. It's like a 10 volt cap. There it is. How you doing, son? You okay? You gonna be alright? You're not okay? Okay. Let's take care of that real quick. What are you crying about? No. What? Okay? She don't play with you right now. What more can you, why don't you get there? So what? She's mad at you, leave her alone. Okay? There's no other answer. It's okay or you're going to your room. Right? There's nothing, I'm not going to go in there and say, hey, you got to play ever again. Okay? What? Why am I not going to do that? Because that's wrong. Me doing that would be wrong. Alright. Then you're going to leave me alone, okay? You understand? Alright. Caleb's out here crying. You need to play with him. Well, he's ready to say he's sorry. Right. Caleb? Go. Dude, say you're sorry. Wow, I don't even know. Being a dad is awesome. That's all I gotta say. The answerless problems. Problems with just no answer. So I say, let it go. Figure out another thing to worry about. Well, I don't know. It's pretty simple. We're getting about 12 to 15 volts on the bridge rectifier, and then that shoots through to the third transistor, firing off the third coil. way too much stuff going on here though. You can hear it when it's working. It's working now. It's two 26 gauge drives on that right now. 1364. And now there's the third drive running with no current. There's no current going through this right now. You can hear that. And this thing is never going to generate enough current to run itself, ever. It's just never going to happen. Now with solid state stuff, it's a totally different story. Like Rodin coils, Tesla coils, all this stuff, all the solid state stuff doesn't need to move. Okay, so you don't really need current. You probably get a lot of current through it though. You don't really need current unless you have a tremendous load. Oh, you just put a little bit of voltage in, you'll get enough current to run a load. You know, it's a totally different ball of wax. And alright, hold on just a second. I think having something move requires current. Alright, now need a piece of tin foil. Here we go. That was easy. Dumb cat. Jesus. I mean, when they go under your feet like that, it's like they really want to die. They want to get stepped on. And they want like their kidneys or their liver to explode. That's not what they really want, but that's how you feel that they want it because, you know, it makes you feel so terrible to be stuck on. And then, you know, if you didn't step on the right way, yeah, that happened once actually, so I know what I'm talking about. All right. Let's get a tack reading on this. So this is the series circuit in the primary drive with a diode for direct connection between the two. $1600. 1700. Alright, so the double strand here definitely takes away a lot of speed. Even with the other two drives, we're only getting 1788. But that's nice and steady. That's very steady. 1800 basically. Alright, I'm going to turn that off. And we're going to try just the 18 gauge. There it goes. And then we're going to do just the 20. I think this one's going to be the fastest.